Okay, now, first of all, let's look at linear law first. Okay, now, let's look at how linear law come about. Okay, how scientists use linear law to solve the unknown or to find the unknown of the complicated relationship, okay, between the variables. Now, for example, this is the relationship between x squared, x and y. What is x and y? Let's make some assumption over here. X is the surrounding temperature of a bacteria. Okay. Y represent the growth rate of the bacteria. So the scientists actually have how would say has postulated. I mean, he have through some experience, he think the relationship between the x and the y is actually related by this equation. Okay, but then he do not know what is the value of a and b. Okay, he doesn't know the value of a and b. The linear law is used by a scientist to establish the unknown, the a and the b. Okay, now let's proceed from here. In a lab, a scientist can set a different value of x. I mean, he can set a different surrounding temperature where the bacteria is. He can do a different value of x. That means he can set a different surrounding temperature. Okay, and then he go and look at the response. Okay, the response is how is the growth rate of the bacteria. What he do is when he set a value of x, he go and measure the different value of y. Then he change the value of x, that means he change the temperature. He go and measure the growth rate of the bacteria when x is changed to a new value. Okay? That means he have a input value. Input means the temperature, where he can alter the temperature. The output value is which is the growth rate, which he measured, which is the effect. Okay, the cause is the x when he change the temperature. The effect is the different growth rate. Okay, so in the lab, when he changed the temperature, the x, he got a different value of x. He changed the temperature again, he measure again, he got different value of y. That means in the lab, he can obtain a set of x and the corresponding value of y. Okay, you got it? That is the scenario of the how x and y can be obtained, a set of x and y. Okay, now let's come over here. At this particular juncture, the scientist postulate, I mean, he somehow, through some trial and error, he come to the conclusion that the relationship between the x and the y are related in this manner. But he do not know the a and the b value. Okay? He does not know a and b value. But fortunately, using the linear law, he can actually transform the equation into a linear format. Okay? That means from this one, he can convert into this. Okay? What is the advantage of a linear law? Because linear law, when you can draw the line, the gradient is equal to m. Okay? And then the c is actually the y-intercept. Okay? So in this linear law, y and x can be x alone, can be y alone, or any combination of x and y. Can be x plus y, x minus y, x over y, y over x, x squared over y, x over y squared. Can be any combination. This big X and this big Y. Okay. Now, then, what about M and C? M and C can be the unknown, which is A or B or any combination of A and B. That means M can be A over B, B over A square over B. Okay. X can be A plus B, A minus B, B over C, it can be any combination. Okay, now, so after using this, okay, whatever your big X here that you establish, whatever your big Y establish, okay. So if the big X is a X square, so you just from X you square it, you get this value, okay, of X, the big X, which is the different value of X which you square it. Let's say this is X squared. Then similarly, Y can be X over Y. Okay, this is just an example, X over Y. So what happened is, I take the X divided by Y, I get this value. Okay, I take the X divided by corresponding value, I got another big Y. Okay, so but this where what value of big Y will depend on what it is. If you have X over Y, then take the X value divided by Y lah. Oh, okay. So this depends how you work out the big X and the big Y. Okay, now the last part is how do you obtain the A and B value. From the gradient of, once you have obtained this value, when you plot it on a graph for the big X, the big Y versus the big X, you got a straight line, okay, from a straight line. And then why is it straight line? Because you look at this is a standard form for a linear equation. Okay, this is a standard form. If you have this, you will draw a straight line. Whatever you draw will be a straight line. So if a straight line, the gradient of the linear line drawn using the big X and the big Y is actually equal to M. And then the y-intercept from the line is also equal to C. Okay, this is y-intercept. So you actually can obtain the M and the C value. Okay, you can obtain the M and the C value from the straight line. Now, depend how do you, when you modify this original equation into mx plus c, okay, when you modify into this, the m value, okay, that you obtain can equate to, the gradient can equal to the m. The m can be a combination of a and b, or can be a alone, or it can be b. Okay, so once you obtain the gradient, you equate to m. Okay, let me repeat. The gradient value of the line is equal to m. You can obtain the value from the graph. Okay, and then m actually, for when you do the transformation into the linear equation, your m can be a, can be b. Okay, as I say here, it can be also a combination of okay, m and c can be the unknown a, b, or any combination of a, b. But then the thing is, you can form an equation. Okay, m is equal to the gradient of the line is equal to m, and this m can be a combination of a, a b, or a combination of a and b. Similarly, for the y-intercept, you can obtain the value from the graph, okay, from the straight line, and from there you equate to c. Okay, c also, as I say, can be a or b, or combination of a and b. From there you form the second equation. Now that will put you in a situation with two unknown, two equation, similar to like simultaneous equation, two unknown. With that, taking the two equation, you can solve the a and b. That is how linear law is being used to solve very complicated equation. Okay. The next video I will show you how to do the two example here. Okay. But what I teach you here is the basic of linear law. How is linear law being used by research or scientists to solve complicated equation which have unknown inside.